Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to talk about heap sort. A very good afternoon, fun learning. I guess evening ho gayi hai, but that's fine. All right. So, yesterday we had the discussion over two more algorithms. We talked about selection sort and insertion sort. तो जितनी भी sorting techniques हम कर रहे हैं, हर sorting technique के लिए we are discussing three properties. हम लोग check कर रहे हैं कि जो भी sorting technique है, whether that is in place, that is stable, that is adaptive. Apart from that, we have also talked about their worst case time complexities and best case time complexities. Today we will be talking about heap sort, but I'll not be directly jumping into the heap sort. So basically, ज़्यादा time हम लोगों का जाएगा in understanding the concepts of the heap tree. What is a heap tree? मैम लाइव क्लासेस का स्केड्यूल क्या है सीक्वेंस में होती है ना बिल्कुल सीक्वेंस में होती है अगर आप सीरीज में देखोगे तो जो टॉपिक्स है वो भी सीक्वेंस में है जो क्लासेस हैं वो भी सीक्वेंस में यूट्यूब क्लासेस भी और मास्टर क्लासेस भी और हर सेशन के एंड पे मैंने स्केड्यूल डिस्कस किया हुआ है अगर आपने नहीं देखा है तो जस्ट गो थ्रू इट और वेट आज वाले सेशन के एंड पे भी आई बी डिस्कसिंग द स्केड्यूल वैसे मैं ओवरव्यू के लिए बता देती हूँ कि डेली मंडे टू फ्राइडे हमारी गेट की क्लास 4 पीएम पे होती है और दैट इज यूट्यूब क्लास जिसमें हम कॉन्सेप्ट्स कवर करते हैं एंड वी हैव द मास्टर क्लास इन विच वी आर कवरिंग द प्रीवियस ईयर क्वेश्चंस that is at 8 p.m. on the Testbook platform. That is a master class. तो master class is completely free. आपको उसके लिए subscription की जरूरत नहीं है. Okay? तो टॉपिक सारे रिलेटेड है फॉर एग्जाम्पल वी कवर्ड द एप्लीकेशंस ऑफ डिवाइड एंड कॉन्कर आफ्टर दैट वी टॉक्ड अबाउट द सॉर्टिंग टेक्निक्स अब नेक्स्ट वीक से कल और परसों वीकेंड आ गया सैटरडे एंड संडे आई विल नॉट बी टेकिंग एनी सेशन फॉर द गेट बैच सो नेक्स्ट सेशन विल बी ऑन मंडे मंडे को हम नेक्स्ट टॉपिक स्टार्ट करेंगे दैट इज ग्रीडी टेक्निक. All right, so let's start with the heap tree. Anyone having any idea that what are these heap trees? We have heard about the binary tree, we heard about the AVL tree, binary search tree. What is this heap tree? Very good evening, target government exam. Nice name. तो ये heap tree क्या होता है? Because the complete concept of heap sorting is based on heap tree और वैसे भी data structures में heap tree का concept है ये. So let's cover it here. Min or max tree. Okay, min heap tree or max heap tree. What is the condition for? Okay, हमारे पास एक आंसर आया कि ये जो heap tree होता है ये आपके पास min heap tree और max heap tree हो सकता है. क्या ये इसकी definition है या इसकी types है? Very good evening, Kanchan. That's correct. We have min heap tree and max heap tree. But is this the definition for heap tree? I guess these are the types for heap tree, right? कि हमारे पास heap tree, max heap tree भी हो सकता है और min heap tree भी हो सकता है. Yes. तो ये types है. मैंने आपसे पूछा कि heap tree क्या होता है? My question is, what is a heap tree? We'll talk about the types later. But first of all, we need to identify that what is this heap tree? What is this tree representing? What are its properties? So heap tree is nothing but this is also known as the priority queue. Priority queue means depending on the priority of the element, we are taking out the element. Okay, so priority queue is the abstract data type. Here, if we talk about the operations that can be performed, that's the insertion or the deletion operation. Basically, कोई भी data structure है जो basic operations है, you can perform the insertion operation or the deletion operation. But when can we say that a tree is a heap tree? When it satisfies two properties. A tree is said to be heap tree if and only if a tree is said to be if and only if it satisfies two properties. And first property is the structure property. सबसे पहले structure property को follow करेगा. It is complete binary tree. Yeah. So it has to satisfy two properties. First one is a tree has to be a has to be an almost complete binary tree. ऑलमोस्ट कंप्लीट बाइनरी ट्री का मतलब क्या है? ट्री के सारे लेवल्स फुल होंगे एक्सेप्ट फॉर द लास्ट लेवल. There is no restriction on the last level. So this is almost complete binary tree. This is about the structure property. Almost complete binary tree. This means that all the levels of the tree should be full. This means all the levels of the tree should be full except last level. क्योंकि अगर मान लो आपके पास चार एलिमेंट्स आ रहे हैं एंड वी आर कंस्ट्रक्टिंग अ बाइनरी ट्री, वी आर हैविंग अ बाइनरी हीप ट्री, तो उस केस में लास्ट लेवल पे लास्ट लेवल कैन नॉट बी फुल. बट हियर द कंडीशन इज at the last level elements should be kept, elements should be kept on the leftmost available position, leftmost available position. इसका क्या मतलब है? If I'm saying we have a tree, okay, this is known as, I'm calling this as a structure property. So the very first condition that has to be satisfied is this structure property. आप कोई भी element insert कर रहे हो या delete कर रहे हो, सबसे पहले हम लोग structure देखेंगे tree का. This means that if we have three elements, so obviously this will be full. This is okay, if we have four elements, so I'll be placing this four next level पे जाना पड़ेगा because previous level is full, but next level पे जाकर आपके पास चार possibilities थी. I could have constructed the tree like this. Okay, this already we have considered. चार possibilities के fourth node यहाँ पे हो सकती है. This is according to the binary tree. This is another possibility, right? Last level पे आपके पास चार possible positions थी, but almost complete binary tree means the last level पे जो element होगा that should be kept at the left available position. This is not allowed in ACBT. This is not allowed in ACBT. This is not allowed in ACBT. ये point clear हुआ? So element should be kept on the leftmost available position. This is almost complete binary tree. Second point, it should satisfy the heap property. Second one is it should satisfy the order property. Order property के आप elements को कैसे arrange करोगे? That is known as the order property. So in the order property, we have two properties: max heap property, max heap property, and next one is min heap property. Min heap property. Min heap property says that जो parent होगा that should be smaller than both of its children. Parent is min है तो minimum value होनी चाहिए. Parent is smaller than, if it's a binary tree, let me call this as a binary tree. So parent is smaller than both of its children. Whereas max heap tree नाम से समझ में आ रहा है, parent should be maximum. So parent is greater than both of its children. Make sense? So these are the two properties that needs to be satisfied. First property is the structure property and second property is the order property. Ye clear? Guys, is this clear? So a tree is said to be heap tree if and only if it satisfies the structure property and it satisfies the order property. यही दो steps हम follow करेंगे. Doesn't matter whether we are performing the insertion operation, we are inserting an element in a heap tree, or we are deleting the element from the heap tree. Okay, deleting the elements one by one from the heap tree is nothing but that is heap sort. तो यानी कि basically heap sort is completely related with the operations performed on a heap tree. Anyone having any doubt in this one? If this is clear, then I'm taking few trees. You just have to tell me that whether that's a tree, whether the given tree is a heap tree or not. अगर heap tree है, तो max heap tree है या min heap tree है? Will it work? So first example, let us assume the elements are 1, tree is 3, then I have 2 here, and next I'm taking 4. Is this tree a heap tree? First one, जो मैंने A में बनाया है, is this a heap tree? Come on, guys. In the first case, whatever tree I have constructed, is this a heap tree? तो कैसे चेक करेंगे? फर्स्ट ऑफ ऑल वी नीड टू चेक फॉर द स्ट्रक्चर प्रॉपर्टी. इज दिस द स्ट्रक्चर ऑफ अ हीप ट्री? सो ऑलमोस्ट कंप्लीट बाइनरी ट्री है. फर्स्ट लेवल पे आपके पास एक ही नोड आ सकती थी, इट इज देयर. नेक्स्ट लेवल पे दो नोड्स आ सकती थी, इट इज देयर. एट द नेक्स्ट लेवल वी कैन हैव वन नोड एंड दैट इज अवेलेबल ऑन द लेफ्ट मोस्ट पोजीशन. सो दिस मीन्स दैट स्ट्रक्चर प्रॉपर्टी इज सेटिस्फाइड हियर. It satisfies the structure property. Now check for the heap property. Parent is smaller than both of its children. That's fine. Parent is smaller than its children. एक ही child है, so it's smaller than that. So this means that this satisfies the order property as well. किसकी order property है ये? Min heap की. So this means that given tree is a min heap tree. This is a min heap tree. Now check for the next one. 1 is okay. Let's check for structure property here. अगर structure property satisfy होती है, then only we'll go to the order property. So here, this node is at first at the root level will be having one node, that's fine. At the next level will be having two nodes. This level is also full. Next node next level पे जाएगी. But here two empty slots are there. जब आपने tree की representation देखी होगी, there are two ways to represent a tree: linked list representation and array representation. अगर आप इस tree को array में represent करोगे, somewhere in the middle you will be getting the empty slots. So there should not be any empty slot available if we are talking about the heap tree. So this is not allowed. So this means that the given tree is not satisfying the structure property. So we'll not look for order property. Okay. Is this clear? So since it does not satisfy the structure property, so we can say that this is not a heap tree. Forget about min heap or max heap. Order हम check करेंगे नहीं जब तक structure ही satisfy नहीं हुआ. So this is not a heap tree. Check for the next option. Again, I'll check for the first condition whether the structure property is satisfied. At the root level, only one node is allowed. It's present. At the next level, two nodes. At the next level, three nodes are there, but all the nodes are kept to the leftmost available position. So definitely it satisfies the structure property. So can I say that this is a heap tree? Structure property is satisfied by the given tree. What about order property? If yes, if order property is satisfied, then let me know which tree is this. Come on, guys. मेरी वेबसाइट व्हाट मेरी वेबसाइट एक एई एग्जाम है मैम, कंप्यूटर साइंस से क्या पढ़ना है, कंप्यूटर साइंस फुल सिलेबस. We'll talk about this general query towards the end of the session. Right now, we'll be just focusing on the concept. Target government exam, I'm going to put your query on hold for another 20 to 25 minutes. Okay, let's finish with this concept क्योंकि जो आपकी query है वो थोड़ी सी off the track है. Off the track means जो अभी इस time पे topic चल रहा है, it's not related to that. Okay, hurry up guys. 4 बजे कौन सा सोने का टाइम होता है? Come on, order property is satisfied or not? If yes, then this tree is a max heap tree or min heap tree. चेक करके बताओ कि इस ट्री पे कौन सी प्रॉपर्टी सेटिस्फाई हो रही है. ऑर्डर प्रॉपर्टी सेटिस्फाई हो रही है. अगर स्ट्रक्चर प्रॉपर्टी और ऑर्डर प्रॉपर्टी दोनों सेटिस्फाई हो रही हैं तो हम बोलेंगे कि ट्री हीप ट्री है. तो यहाँ पे ऑर्डर प्रॉपर्टी सेटिस्फाई हो रही है. फटाफट से चेक करके बताओ. Whatever order property is satisfied, it should hold true for all the cases, for all the nodes. 10 is smaller than both of its children, looks like min heap property, क्योंकि smaller min में आता है. 40 should be smaller than both of its children, but here 40 is neither smaller than both of its children. 60 से smaller है but 20 से greater है. So this is neither minimum nor maximum. So ना तो ये min है और ना ही ये मैक्स हीप की प्रॉपर्टी सेटिस्फाई कर रहा है. मोर ओवर जब भी हम ट्री कंस्ट्रक्ट करते हैं, इफ इट्स अ min heap tree, then for every node of a tree it should satisfy the min heap property. If it's a max heap tree, then for every node of a tree it should satisfy the max heap property. Combination of both is not allowed. But here it's neither a max heap tree nor a min heap tree since the order property is not satisfied. So we will say that this is not a heap tree. Make sense? Any doubt? Now we'll talk about the minimum and the maximum number of nodes. Uh, in a heap tree, what will be the minimum or the maximum number of nodes? ट्री के बेसिस पे क्वेश्चन करने का सबसे इजी तरीका मैंने आपको क्या बताया हुआ है कि फॉर्मूलाज को याद मत करो, ट्री बना लो. हाइट और लेवल्स आपको पता है कैसे फाइंड करते हैं. जस्ट ट्राई टू रिलेट इट विद द फॉर्मूला. Okay, those who are following this session for the first time, guys, we have an official Telegram group that is Shefali ma'am Testbook. इस ग्रुप में मैं जितने भी सेशंस होते हैं YouTube पे मैं सबका लिंक शेयर करती हूँ. उसके अलावा जो जब सेशन खत्म होते हैं, सेशन के एंड पे आई शेयर द PDF ऑफ ऑल द YouTube सेशंस. लाइक जो अभी सेशन चल रहे हैं इसकी PDF आपको ग्रुप में मिल जाएगी. इसके अलावा अगर आपकी कोई क्वेरीज हैं, कोई डाउट्स हैं तो आप अपना टेलीग्राम ग्रुप में डाल सकते हो. यू कैन डायरेक्टली इंटरेक्ट विद मी. आप क्विज और पोल में भी पार्टिसिपेट कर सकते हो. सो दिस इज द ग्रुप दैट इज शेफाली मैम टेक्स्ट बुक और इसका लिंक आपको वीडियो की डिस्क्रिप्शन में मिल जाएगा. डिस्क्रिप्शन में दैट इज द थर्ड लिंक आगे लिखा हुआ है. दैट इज द लिंक फॉर द टेलीग्राम ग्रुप. सो यू कैन ज्वाइन द ग्रुप फ्रॉम by following that link. Okay, all right. Next one, construct max heap tree for the following elements. अब हमें ये समझ में आ गया. Okay, I was thinking about discussing one more concept. All right. ट्री कंस्ट्रक्शन से पहले हम यहाँ पे एक कॉन्सेप्ट डिस्कस करते हैं. हाउ टू रिटर्न द मिनिमम एंड द मैक्सिमम नंबर ऑफ नोड्स. आई वांट यू टू रिटर्न द मिनिमम एंड maximum number of nodes in her heap tree. कितनी nodes आएंगे, minimum और maximum? Let's say we do not know, so let me try finding out the nodes with the height 0. Root level is at height 0. Then with height 1, with height 2, with height 3, इस तरीके से हम फाइंड करेंगे. So minimum number of nodes and maximum number of nodes. Height 0 means we are talking about the root level. What will be the minimum and maximum number of nodes? I'm not asking for the formula. I'm just asking for the number of nodes. If the height is 0, that means the root node is available. So minimum भी एक ही होगी और maximum भी एक ही होगी क्योंकि root level पे हमारे पास एक ही node होती है. So with height 0, minimum number of nodes are 1, maximum number of nodes are also 1. With height 1, minimum number of nodes, height पहले tree की height 1 करनी पड़ेगी. So I have taken a tree with height 1. Since I want the minimum number of nodes, so I'll just stop here. So in this case, the number of nodes are 2. If I want to find out the maximum number of nodes with height 1, I'll take a tree with height 1. This is a tree with height 1. Since I want the maximum number of nodes, so all the levels will be full. This is coming out to be 3. With height 2, तरीका क्या है? एक tree बनाओ with the height 2. This is a tree with height 2, but this is not a heap tree. क्योंकि heap tree ने क्या बोला कि आपके पास levels previous level should be full. Next level पे जाने से पहले previous level should be full. So level 1 should be full. This is full. Now minimum number of nodes, I'll not be adding any more nodes here. So in this case, minimum number of nodes that we are getting is 4. With maximum number of nodes with height 2, this is a tree with height 2. Maximum means सारे levels completely full होंगे. This is full. So here we are getting 7 nodes. Are you getting this? With height 3, how many minimum nodes will be there? Minimum number of nodes with height 3. Height 2 वाला complete होगा tree. ये पूरा tree आएगा 1, 2, 3, 4, 5, 6 and 7. Then it will be going to the next level. So here the number of nodes are 8. If you see here, the maximum number of nodes will be 3, 4, 5, 6, 7, 8, 9. I'm sorry. This is full. So if you see here, the number of nodes are 15. अगर मुझे number of nodes return करनी है with height h, what will be that? Number of nodes with height h. यहाँ पे relate करके देखो, अगर height 0 है, then it is returning 2 raised to power 0. If it is 1, then it is returning 2 raised to power 1. If it is 2, then it's returning 2 raised to power 2. If it is 3, then it is returning 2 raised to power 3. Yes? Or so if I want to find out the number of nodes with height h, then it will be 2 raised to power h. This is representing the minimum number of nodes with height h. Minimum number of nodes with height h. I'm explaining, अगर आपको कभी भी confusion हो, tree का कोई भी formula है, आप instantly उसको derive कर सकते हो. This is representing the minimum number of nodes with height h. Similarly, here we'll find out the maximum number of nodes. Maximum number of nodes are, this is 2 raised to power 0. This is 2 raised to power 2 minus 1, 4 minus 1. This is 2 raised to power 3 minus 1. This is 2 raised to power 4 minus 1. So if I write this, this is nothing but height is what? 1. So it is 1 plus 1 minus 1. This is 2 raised to power 2 plus 1 minus 1. This is 2. Okay, this is going behind the image. So let me switch it off. Hope it's visible now. Now it can be written as 2 raised to power 3 plus 1 minus 1. So if height is 3, I'm writing 2 raised to power 3 plus 1. If height is 2, I'm writing 2 raised to power 2 plus 1. Height is 1, then I'm writing this as 2 raised to power 1 plus 1 minus 1. If it is height 0, I can write this as 2 raised to power 0 plus 1 minus 1. So if I want to find out the number of nodes with height h, number of nodes with height h, it will be 2 raised to power h. अगर यहाँ पे value 3 है, then it is 3 plus 1 minus 1. So it comes out to be h plus 1 minus 1. Make sense? So this is the formula for maximum number of nodes, maximum number of nodes with height h. इसमें किसी को कोई डाउट? Guys, इसमें किसी को कोई डाउट? So here we have discussed two formulas. You can expect a straightforward question from the formulas. Formula for finding the minimum number of nodes in a heap tree, formula for finding the maximum number of nodes in a heap tree. Is this clear, guys? Yeah, come se come confirmation though. We have not even started with the inserting the elements in a heap tree. Let's consider here few elements. यहाँ तक बेटा कोई doubt है? Now I want to construct a heap tree. Let's go for the construction. Construction of a heap tree. There are two methods for constructing a heap tree. One is adding the elements one after another. Adding elements one after another. And second method is the build heap method. So these are the two methods. Build heap method. So these are the two methods for the construction of a heap tree, for inserting the element in the heap tree. Okay. So if in the exam they are asking for the minimum number of swaps, will be following the build heap method. Agar aapko bola hai, what will be the number of swaps? If the elements are added one after the another, तो आपसे number of swaps पूछे जा सकते हैं heap tree construction के basis पे. They may ask for the resultant heap tree. तो आपको ये identify करना पड़ेगा कि whether you are going to follow the one after another or the build heap method. I'll be taking one example and we'll be doing the comparison and we'll see that how build heap method is returning the less number of swaps as compared to one after another. Name itself suggests that, first of all, I'm taking the example for the one after another, adding elements one after another. Let me consider the worst case scenario, or let's take some unsorted array like 5, 3, 1, 6, 9 and 15. 15 and okay, let's stop here. पहले example है छोटी लेते हैं. So I am not taking neither the best case nor the worst case. I'm just taking some unsorted array and I want to construct a heap tree from the given set of elements. So what we'll do is we'll look for two properties. फर्स्ट वन है स्ट्रक्चर प्रॉपर्टी. जब भी एलिमेंट नया एलिमेंट आएगा सबसे पहले हम स्ट्रक्चर प्रॉपर्टी देखेंगे. वी हैव टू फॉलो, वी विल बी एडिंग द एलिमेंट विच विल सेटिस्फाई द स्ट्रक्चर प्रॉपर्टी. उसके बाद हम ऑर्डर प्रॉपर्टी को सेटिस्फाई करवाएंगे. दिस इज द सीक्वेंस. So when the first element is coming up, initially the tree is empty. Initially कोई element नहीं है, तो definitely 5 will be added and there is no swap taking place. Now I want to insert the next element. तो next element कैसे insert करेंगे? It should occupy the position according to the structure property. Root level तो full है. Root level is full. So it should, I'm not doing the modification here ताकि आप differentiate कर पाओ. Now 3 should be on the left or right of 5. Where should I add this element 5? According to the structure property, the next element will be added where? Any idea? According to the structure property, next element should go where? Because this level is full, so we need to go to the next level, and at the next level, whatever is the first available position, that is on the leftmost position, we will be adding the new element. अभी तक हमने यहाँ पे कोई order property नहीं देखी है. To the left of 5. Now we'll check for, let's assume we are constructing the max heap tree. We are adding the elements and we are constructing a max heap tree. I want to return a max heap tree. तो अब max heap tree की हम order property check करेंगे. Order property says that parent should be greater than its children. So here parent is greater than its children. 5 is greater than 3. Yes. So no swapping will take place. Now we'll consider, second step is over. Now we'll go for the next element, that is 1. According to the structure property, 1 will be added on the right of 5 because that is the next available position. Now we'll check for the order property. जो आपने नया element add किया है, is it greater than the parent? No. So in this case also no swapping is taking place. Take the next element. Where should I add this element according to the structure property? It will be going to, मैं step by step कर रही हूँ क्योंकि ये पहला equation है. This is coming as it is. Next element will be added to the next level and to the leftmost position. So that is 6. Now this new added element is greater than its parent. हमें max heap tree चाहिए, but parent should be greater. So this does not satisfy the property of the max heap tree. So we need to perform the swapping here. These two elements will be swapped. 3 will be swapped with 6. Again, we'll check whether the child that is updated right now, is it greater than its parent? Yes, 6 is greater than its parent. So again, second swap will take place. It comes out to be 6 and here we'll get 5. This means that when I inserted the element 6, 2 swaps are taking place. And the resultant tree that we are getting here is, it's 6, 5, 1 and 3. Is it a max heap tree? Yes. Now take the next element. This way we will be adding the elements. So हम 9 को कहाँ पे add करेंगे? To the right of 5. Since this element is greater than its parent, so it will be swapped. 9, it will be swapped. Here we'll get 6. So how many swappings took place? Worst case में ज़्यादा से ज़्यादा swappings कितनी होंगी? जितने आपके पास tree में levels हैं, right? So this is resulting into 9, 6, 1, 3 and 5. This method is known as one after another because one by one we are adding the element. एक element add करते हैं structure property के according, फिर order property satisfy करवाते हैं. Then we go to the next element like this. So that's why this is known as the one after another. Next one, I want to insert the element 15. So 15 will be added somewhere here. Now we'll check for the order property. It will be swapped with 15 and here we'll get 1. This will be swapped with 15 and here we'll get 9. So here also 2 swaps are taking place. So finally the resultant tree is coming out to be 15, 6, 9, 3, 5 and 1. एक एक करके आप सारी notes के लिए check कर सकते हो. Root is greater than both of its children. 6 is greater than both of its children. 9 is greater than its child. So definitely this is a max heap tree. Okay, and if in the exam it's asking for the number of swaps, so we have already written for first 3 elements no swap was taking place, but for the last 3 elements, for each element 2 swaps were taking place. So total number of swaps comes out to be 6. अगर एग्जाम में रिजल्टेंट ट्री पूछे तो this will be the answer, and if it is asking for the number of swaps, then you can return this. Okay, now let's consider one example which will be solving with build heap method as well, so that we can identify that what will be the time complexity. Okay, I want to construct a min heap tree. Here we have constructed the max heap tree. Okay, now I want to construct a min heap tree. Min heap tree by adding the elements one after another. Now I'm taking the elements in the reverse order. For example, 7, 6, 5, 4, 3, 2, 1. 4, 3, 2 and 1. I want to add these elements. So one by one we'll be adding the elements. अब मैं हर एक element के लिए अलग से tree नहीं बनाऊंगी. 7, this is the smallest element. Only one element is there. No swapping is going to take place. And next element will be added to the left of 7 according to the structure property. Now 6 is smaller than 7, so we'll be swapping these elements. Here we'll get 6 and 7. So one swap is taking place. For 5 will be added to the right of 6 because this is the next available position. Now we'll check for the property, order property. 5 is smaller than its parent and we are constructing the min heap tree. So 5 should be the parent node. So these two elements will be swapped. Here we'll get 5 and here we'll get 6. So one swap is taking place. Now next element will be going, this is a min heap tree. I'm going to add the next element, that is 4. 4 will be added. This level is completely full, so we need to go to the next level and it will be added to the left. Now check for the order property. 4 is smaller than its parent, so it will be swapped with 7 and here we'll get 4. 4 is smaller than its parent, so it will be swapped here. Here we'll get 5 and here we'll get 4. As of now, we are getting 4, 5, 6 and 7. Is it a min heap tree? Yes. When we had added 4, 2 swaps are taking place. Those swaps are there, right? प्रशांत ये emoji क्या खेलते रहते हो आप? ये clear हुआ? Now let's add the next element. Next element is 3. सबसे पहले according to structure property 3 will be on the left of 5. अब हम order property satisfy करवाएंगे. 3 is smaller than 5, so the swapping will take place. 5 and 3. 3 is smaller than its parent, so again the swapping is going to take place. So 2 swaps are taking place here. Next, 2. 2 will be added at the next available position, that is to the left of 6. Now, if you see here, 2 is smaller than 6, so swapping will take place. First swap is taking place, and then 2 is smaller than its parent, so second swap is also taking place. 2 will be swapped with the element 3. So for insertion of 2, 2 swaps are taking place. Next one, last element 1. 1 will be added. So as of now, we have 2, 4, 3, 7, 5, and 6. Now I want to insert a new element to the existing heap tree. I'll be adding the element 1 according to the structure property. It should be on the right of 3, but 1 is smaller than its parent, so it will be swapped. Now 1 will be swapped here. So 2 swaps are taking place. Finally, the resultant min heap tree is 1, 4, 2, 7, 5, 6 and 3. मैं कुछ properties discuss करूँगी, कुछ points discuss करूँगी on the basis of this example, and that can be asked in true and false. Okay. So first thing is, if they are asking for the resultant heap tree, तो ऐसा नहीं है कि हमेशा दोनों children में से जो greater होगा that will be on the right side and smaller one will be on the left side. This is not the hard and the fast rule. And here in this case, if you see, if it's a min heap tree, minimum element is always at the root. That means अगर min heap tree है तो हमेशा आपको smallest element root पे मिलेगा. If it's the max heap tree, then it's always the maximum element that you will be getting at the root. Okay? अगर max heap tree है तो minimum element will be at the root. अगर min heap tree है तो minimum element will be at the root and maximum element will be at the leaf level. Okay, these are few statements which were all asked in the exam. In true or false, you will be given with 4 statements, and they'll say and they'll be asking that which of the given statement are true. Okay, तो इस तरीके से आ सकता है. And if here we were supposed to return the number of swaps, तो कितने swaps आए? Number of swaps with one after another method. For first element, this is taking one swap with one swap. Then for remaining elements, it's taking 2 swaps. So in total, 10 swaps are taking place in order to get a min-heap tree from the given set of elements. Make sense? Guys, is this clear? किस टाइप के क्वेश्चंस आ सकते हैं? मैंने 3 टाइप्स डिस्कस किए हैं. आपसे रिजल्टेंट हीप ट्री पूछ सकते हैं. दे मे आस्क फॉर द नंबर ऑफ स्वैप्स, or they may give you few statements on the basis of the heap tree, and you have to find out the correct or the incorrect statements. Okay. All right. Now there is one more method for constructing the heap tree, that is using the build heap method. अभी हमने जो discuss किया method, that was one after another. Next one is build heap method. Build heap method क्या बोलता है कि जो भी आपको elements given है सबको insert करवा दो एक साथ. Build heap method. So here I want to construct, let's assume, the heap tree with the elements 7, 6, 5. I'm taking the same example. 4, 3, 2, 1, and from these elements I want to construct the min heap tree. Okay, construct the min heap tree using build heap method. But exam में कभी भी आपको ऐसा नहीं given होगा construct the min heap tree with the build heap method. They might be asking that what will be the minimum number of swaps. Minimum number of swaps required to construct a min heap tree. अब यहाँ पे आपको कोई मेथड नहीं बताया कि आपको कौन सा मेथड फॉलो करना है. तो जब भी आपको मिनिमम नंबर ऑफ स्वैप्स पूछे होंगे, विल ऑलवेज गो फॉर बिल्ड हीप मेथड. ओके, प्लीज डू टेक केयर ऑफ दिस पॉइंट, बिकॉज समटाइम्स स्टूडेंट्स आर लाइक कि मैम वहाँ पे मिनिमम नंबर ऑफ स्वैप्स पूछे थे तो कौन सा मेथड यूज करना था. सो इट्स द बिल्ड हीप मेथड. आई विल प्रूव दिस पॉइंट व्हाई इट्स द बिल्ड हीप मेथड. बिल्ड हीप मेथड क्या बोलते हैं, जितने भी आपके पास एलिमेंट्स हैं सारे एलिमेंट्स को ऐड कर दो अकॉर्डिंग टू द स्ट्रक्चर प्रॉपर्टी. इन वन गो विल ऐड ऑल द एलिमेंट्स, will not look at their order property as of now. So 7 पहला एलिमेंट आया तो रूट लेवल पे जाएगा. नेक्स्ट एलिमेंट will be on the next available position, then this level is full, will be going to the next level, 3, 2 and 1. Okay, we have added all the elements according to the structure property. Now we'll start looking for the order property starting from the first internal node. First internal node means आपके पास if you start from the last element, this is not the internal node, not the internal node. I'm going in this direction. This is not an internal node, not an internal node. So this is the first internal node. ओके तो आप कैसे फाइंड कर सकते हो, फॉर i इज इक्वल टू, अगर टोटल आपके पास n नोड्स हैं, then we know that almost half of the nodes are the leaf nodes. So here it is n by 2. 7 by 2 is 3.5. We'll be taking here flow value. So that is resulting into 3. So we'll start from the node. If this is 1, this is 2, this is 3, we'll start heapifying the tree from this node. And we have to do this process for all the internal nodes. 3 ke liye index 2 pe jo node available hai, index 1 pe. So it will be decreasing the value down to 1. 1 tak root level tak jayega. So here we'll be executing a for loop. What we need to do is for each internal node, we will be looking for its heap property. So 5 is smaller than both of its children? No. So here we'll heapify it. 5 will be swapped with 1 or 2. Obviously it will be swapped with 1 because 1 is the smallest one. 1 and 5 are swapped. Now this subtree looks like a heap tree. So if I'm finding out the number of swaps, अगर मैं number of swaps calculate कर रही हूँ तो first swap हो गया. Now this node is heapified. Now we'll go to the next node. हमें n by 2 से शुरू कर कहाँ तक पहुँचना है, 1 तक. तो 3 से शुरू करके 1 तक आना है. तो I'm going to reduce the value of I. Now it is the node available at index 2. Is this a heap tree? No. 6 is not smaller than both of its children. So I'll be doing the swapping with the smallest element. This will be 6 and this will be element 3. Right? So how many swaps took place? Again, one swap is taking place. Now we'll go to the root node. 7 is smaller than both of its children? No, 7 is not smaller. Here we have the element 3 and here we have the element 1. Since 1 is the smallest one, so we'll be swapping 7 with 1. 1 and 7. यहीं पे नहीं छोड़ेंगे क्योंकि जब आपके पास सब लेवल पे कुछ इंटरमीडिएट लेवल पे चेंज हुआ है, इट माइट बी अफेक्टिंग सम अदर सब ट्रीज. सो चेक करेंगे, इज दिस स्टिल अ हीप ट्री? 7 is smaller than both of its children? No, it's the 2. So it will be swapped with 2. So for the first root node, it is taking 2 swaps. So in total, it is taking 4 swaps to construct the heap tree, and the resultant heap tree is 1, 3, 2, 4, 6, 7, and 5. Is it a min heap tree? Yes. 1 is smaller than both of its children. 3 is smaller than both of its children. 2 is smaller than both of its children. So this is the resultant heap tree that we are getting using the build heap method. Okay. And the number of swaps taking place in order to construct the min heap tree using the build heap method is 4. Same example के लिए, same elements के लिए 7, 6, 5, 4, 3, 2, 1 using one after another. If you compare here, we were getting 10 swaps. So it's very much clear that if they're asking for the minimum number of swaps, so undoubtedly we'll go for build heap method. Makes sense? Proof is on the screen. Reason is clear. And second thing is, even if they are asking for the resultant tree, this is also a min heap tree, but min heap tree is, we are not getting a unique min heap tree. 1 के left में 4 है, 1 के right में 2 है. If you see here, 1 के left में 3 है, 1 के right में 2 है. So we'll not be getting the same heap tree using one after another and using build heap method. So if in the exam it is mentioned that what will be the resultant heap tree if the elements are added one after another, that means you have to use one after another. You won't be getting the same result by using the build heap method. ठीक है, तो आप वहां पे फिर build heap यूज नहीं कर सकते हो क्योंकि resultant tree में difference आ जाएगा. ये point clear हुआ? So whenever I'm repeating this point again, I guess this is the third or the fourth time I'm repeating this point that guys, if it's asking for the minimum number of swaps, then do not go for one after another. So you have to decide that which method has to be used under what scenario. If nothing is mentioned, no hint is given, then undoubtedly we'll go for build heap method because the time complexity is less. Okay. अगर हम यहाँ पे हीप ट्री कंस्ट्रक्शन के लिए एक एलिमेंट को ऐड करने के लिए टाइम कॉम्प्लेक्सिटी निकालते हैं, इफ आई वांट टू ऐड वन एलिमेंट हियर इन दिस ट्री, आई वांट टू ऐड वन एलिमेंट, then how much time is required? If n elements are there, with n elements, this is a almost complete binary tree, so what will be the number of levels? Number of levels will be log n. Log n है. अगर एक एलिमेंट को ऐड करना है, फॉर एग्जाम्पल यहाँ पे आपके पास हाइट 2 है, अगर मुझे एक एलिमेंट को ऐड करना है तो ज्यादा से ज्यादा कितनी स्वैपिंग्स हो सकती हैं? इट डिपेंड्स ऑन द हाइट ऑफ अ ट्री. अगर उस टाइम पे हाइट ट्री की 1 है तो ज्यादा से ज्यादा एक ही स्वैपिंग होगी, हाइट 2 है तो ज्यादा से ज्यादा 2 ही स्वैपिंग्स होंगी. सो इफ लॉग एन लेवल्स आर देयर, देन मैक्सिमम नंबर ऑफ स्वैप्स. वर्स्ट केस में जब हम कॉम्प्लेक्सिटी की बात करते हैं, we always consider the worst case scenario. So in order to add one element, and in order to add one element, how much time is it taking? It's taking log n. To add the second element and second element, how much time is it taking? It's taking again log n. So one after another, I want to add n elements. If I'm adding the nth element, that is also taking, हर एक एलिमेंट को ऐड करने के लिए log n टाइम लग रहा है. So if I want to construct a heap tree with n elements, how much time will it be taking? For this one, एक एलिमेंट के लिए log n है, दो एलिमेंट्स के लिए 2 log n हो जाएगा, 3 elements के लिए total time will be 3 log n. For n elements, total time will be, time complexity will be order of n log n. To insert, basically what I have discussed here, to insert n elements, to insert, TC is representing here, the total time required, total time required to insert n elements. This is with one after another. Whereas in case of build heap method, हमारे पास यहाँ पे एक for loop है जो almost half of the elements के लिए हम execute करें. और यहाँ पे जो steps हैं, those are just the comparisons and the swaps. No loop is coming up, right? So this build heap method is going to take, to construct a tree, this is going to take order of n. Time complexity is order of n with build heap method, whereas with one after another it is n log n. ये clear हुआ? I hope that insertion is clear to everyone. Guys, insertion is clear. The way we have inserted the elements in the heap tree, in the similar way we will be deleting the elements from the heap tree. Now let's talk about the deletion. I'm constantly looking at your responses. If any doubt is there, write that in the chat section. Otherwise, I'll simply keep on jumping to the next topics. Okay? क्योंकि बहुत सारे लोग हैं आप में से जो रिस्पॉन्स ही नहीं देते हैं. अगर मैं आपके रिस्पॉन्स की वेट करूंगी, then I'll be in the waiting state. All right, deletion. Basically, the concept of heap sort is based from the deletion. So let us consider one tree here. Watching from beginning, that's fine, but I wasn't getting the confirmation. So how can I be sure that whether you are watching or not? I hope you understand that. Okay, so here we are getting 1, 3, 2. I'm going to copy this tree. 1, 3, 2, 4, and 6. Then we had, what was there? 7 and 5. Okay. So here we had 7 and 5. This is what we got using build heap method. Okay. Now I want to delete the element. कैसे delete करेंगे? We'll be simply deleting the root node. Okay, I'll delete this root node and I'll copy this element somewhere, like we are getting 1, because this is a min heap tree. I'm performing the deletion operation in the min heap tree. Same तरीके से आपके पास max heap के लिए work करेगा. So when from min heap tree I'm deleting any element, I'll be getting the smallest element, right? So I'm getting here 1. बट कभी ऐसा कोई पेड़ देखे जिसकी जड़ें नहीं हो और पेड़ हवा में तैर रहे, दैट इज नॉट पॉसिबल, राइट? देयर कैन नॉट बी एनी ट्री विदाउट द रूट. सो हियर वी नीड टू हैव सम रूट नोड. तो ये रूट को कौन रिप्लेस करेगा? नाउ बोथ द चिल्ड्रन आर फाइटिंग. 3 is saying that I want to take this position, 2 is saying that I want to take this position. और अगर 2 को यहाँ पे भेज दिया, फिर यहाँ पे सब ट्री का कोई पेरेंट नहीं है. सो we know that first of all the structure property has to be satisfied. अब आपके पास ट्री में 6 एलिमेंट्स रह गए. According to the structure property, this node should not be there. So we'll check from the last level. जो भी आपको पहला element मिलेगा, we'll replace it with that node. Okay. I'm deleting first element. Parallelly, I'll be writing the time complexity. Deleting the first element. Basically, I'm discussing the heap sort now. So deleting the first element. So the last element is replacing the root node, and after that we need to check for the heapify property, right? So this is going to take how much time? 5 is smaller than both of its children? No. So this will be swapped with 2. Here we'll get 2 and 5 will be coming here. Swapping is taking place. 5 is smaller than its child? Yes. राइट? तो वर्स्ट केस में एक एलिमेंट डिलीट करने के लिए कितनी स्वैपिंग्स हो सकती हैं? In worst case, the number of swappings that can take place in order to delete one element, that is coming out to be log n. For first element, it's taking log n time. I want to delete, now this is a heap tree. If you observe this, now 2 is the root. Min heap tree है तो minimum element will be at the root. 3, 5, 4, 6 and 7. Now again I want to delete the element, so it's always the root node that will be deleting. So we'll be getting here 2 and this will be replaced with 7. Structure property is satisfied. Now we'll go for the order properties. 7 will be swapped with 3 because the 3 is the smallest element among these. 7 is smaller than both of its children? No. So this is swapped with 4. And here we get 7. So in the resultant tree, we are getting 3, 4, 5, 7, and 6. Right? So this concludes that when we are performing the deletion operation on a min heap tree, every time we'll be getting the minimum element, and when we are performing the deletion operation on the max heap tree, we'll always be getting the maximum element. Make sense? Now this way, one by one, अगर हमें sorting करनी है, sorting means we have to arrange all the elements in the ascending or descending order, यानी कि सारे elements return करने. To delete second element, this is taking log n. To delete third element, that will also be taking log n. For each element, in the worst case, that will be taking log n time. For nth element also, this will be taking the same time. So I can say that if I'm deleting 3 here, this will be replaced with the 6. After that, will be adjusting the tree according to the order properties. 6 is smaller than both of its children? No. So we'll get 4 on the top. And 6 is smaller than 7? Yes. So we'll stop here. So in short, if I want to delete the elements one by one, I'm deleting the elements from the heap tree. So that is going to take how much time? Time complexity comes out to be, in order to delete n elements, n log n time will be taken. N log n time will be taken. तो आपने देखा कि आप जब हम एलिमेंट्स को एक एक करके डिलीट कर रहे हैं, वी आर गेटिंग अ सॉर्टेड ऑर्डर, and this is nothing but this is known as heap sort. This way, when we are deleting the element one by one, this is known as heap sort. And what is the complexity that we are getting here? That is n log n. So we can say that the time complexity for heap sort is, it's n log n. Doesn't matter whether you have बेस्ट केस में भी नंबर ऑफ लेवल्स इतने होंगे, वर्स्ट केस में भी नंबर ऑफ लेवल्स इतने होंगे. बेस्ट केस में भी आप n एलिमेंट्स को डिलीट करवाओगे, वर्स्ट केस में भी आप n एलिमेंट्स को डिलीट करवाओगे. सो द बेस्ट केस एंड द वर्स्ट टाइम कॉम्प्लेक्सिटी रिमेन्स द सेम फॉर द हीप सॉर्ट, दैट इज n log n. Right? So one by one, we are deleting the elements. Now you could have asked, can't we delete all the elements at the same time, like the build heap method when we were adding all the elements and उसके बाद heapify कर रहे थे. अगर आपने सारे elements delete कर दिए उसके बाद sort कर रहे हो, तो that means you are coming back to the original problem. Original problem में आपको already unsorted elements given है. तो in this case, in the scenario of deletion, we cannot delete more than one element at a time. Deletion is always one after the another. Make sense? It's always one after another. ये clear हुआ? Is the concept of heap sort clear? Heap sort is nothing but, again I'm repeating this point, it's just deleting the elements one after the another from the heap tree. If you are deleting the element from the min heap tree, you will be getting the smallest element from all the elements. If you are getting the max heap tree, you are performing the deletion on the max heap tree. Every time you will be getting the maximum element. So according to your requirement, you can place the elements. Is this clear? If it is clear, then let's talk about the properties. Summary about the heap sort. So this is all what I wanted to discuss. डेफिनेटली जो डिटेल सेशंस है उनमें और डिटेल में डिस्कस किया है बाय टेकिंग मोर नंबर ऑफ एग्जांपल्स एंड मोर नंबर ऑफ केसेस. जैसे बिल्ड हीप का हमने कोड लेके डिस्कस, आई गेव यू द एल्गोरिथम, आई गेव यू द आइडिया, बट इफ यू वांट टू कवर एवरीथिंग इन डेप्थ then you can join the super coaching. But इससे आपको थोड़ा बहुत आइडिया हो गया होगा that how heap sort is working. Now you know that we have to return the time complexities. So first of all, time complexity in best case and worst case. Quickly write your answers in the chat section. You know that I'll be discussing the time complexity. I'll be discussing the number of swaps. I'll be talking about number of swaps, that is minimum and maximum, minimum and maximum. And along with this, I want you to return whether the given algorithm is in place, adaptive or stable. Is it in place? Is it adaptive? Or is it stable? We need to do the analysis, right? So quickly write that what is the best case time complexity. I want you to return the time complexity in best case and the worst case. Quickly do the analysis. If you are watching the session from the beginning and you are watching all the sessions, then you must be comfortable with these properties. Right now, we have talked about the best case time complexity and the worst case time complexity, that is n log n. I hope that now you all are comfortable with the time complexities, that how it is coming out to be n log n. Okay, now we want to return the number of swaps, minimum number of swaps. If you are constructing a tree, you are given the elements in the ascending order. आपको elements given है 1, 2, 3, 4, 5 और आपको min heap tree बनाने. This is behaving like a best case, right? आपको max heap tree बनाने, elements are given in the decreasing order. So in that case, is there any swap required? 1, this is a heap tree. 2, this is still a min heap tree. I'm adding the elements one after the another. 3, this is still a min heap tree. 4, still a min heap tree. 5, still a min heap tree. So this means that this input is behaving as the best case for min heap. So how many swaps are taking place here? This is 0. If we talk about the maximum number of swaps, for one element it is taking log n swaps. So total number of swaps that are required here are, it's n log n swaps. Log n is for one element, Lakshita. जब आपने एक element add किया, for that it is log n. But I want to insert, if I'm constructing a tree or deleting the elements from a tree, so that means I need to insert all the elements or I need to delete all the elements. Yes? All right. So first of all, is this in place? Yes, because here swapping of the elements is taking place. मैंने क्या बताया था, इन प्लेस कब होगा, जब आपके पास एलिमेंट्स की स्वापिंग हो रही है. सो इज इट इन प्लेस? यस. इज इट अडेप्टिव? Is it behaving differently in the best case and the worst case? No, so it's not adaptive. Is it stable? एक ही एलिमेंट पता नहीं कितनी बार स्वैप हो रहा है, एक बार स्वैप हुआ उसके बाद फिर से स्वैप हो रहा है, so obviously it is not stable. So this is all about heap sort. If anyone is having any doubt, you can ask. Otherwise, we'll end our discussion. Let me discuss few pointers with you guys. So I'll be sharing this PDF in the Telegram group, that is Shefali ma'am Testbook. इससे पहले वाली PDF भी आपको इस ग्रुप में मिल जाएंगी. तो जितने भी YouTube सेशंस होते हैं सबकी PDF मैं exclusively शेयर करती हूँ with the ink. With the ink means whatever I have written during the session, that will also be included in your PDF. Discussion and doubt solving is there. If you have any doubt or query, you can post that in the group or you can ask that in the live session. कई बार होता है कि live session जब आप attend कर रहे हो तब सब समझ में आ गया, but when you are doing the practice, उस time पे you are stuck at some point, so immediately take a picture and share that in the Telegram group. You can directly interact with me, you can participate in the quiz and the poll. Let me share my screen to show you that here how you can access the link. Okay, so I hope that my screen is visible to everyone. So when I'm going to the description of this video, what is happening? Okay, so let's go to the description. If you see here, the first link is for the masterclass. आप masterclass join कर सकते हो. You can set the reminders in the masterclass. We are solving the previous year questions. So in today's masterclass, we will be solving the previous year questions from the recurrence relation. If you are targeting on NIC, then you can join the NIC Super Coaching. That is the second link. Third link is for the Telegram. This is Join Gate Super Coaching Telegram. This is the link for the group for which I'm talking about. So you can use this link to join the Telegram. And the fourth link is for joining the Super Coaching for the Gate. Super Coaching benefits ये हैं, एक तो आप एक ही सेशन एक ही टॉपिक के ऊपर आपको मल्टीपल सेशंस मिल जाएंगे which are taken by the different educators. And second thing is here you will be getting the complete syllabus in the recorded format. आपको recordings मिलेंगी डिटेल में. Live series में we will be having the quick revision of each and every topic. हर single topic live session में cover होगा, but that will be a quick revision. And a quick revision और detailed session में सिर्फ फर्क इतना है कि सिर्फ examples का difference आएगा. Okay, detailed session में n number of examples are taken for each topic, whereas in the live series, in the quick revision session, we will just discuss the concept, we'll discuss one or two questions, and that's it. And apart from that, there will be separate dedicated doubt solving sessions under the live series. Mock test is also included in this super coaching series. You need not to get it separately. Apart from that, study notes will be given in the PDF format. हर subject के detail और formula notes दोनों मिलेंगे. Engineering mathematics, general aptitude, formula notes, computer science engineering, computer science engineering, there are all the technical subjects are included, so you can have a look over this. But अभी मैं इसको इससे ज़्यादा open नहीं कर सकती because this is logged. I have there is no subscription activated yet, तो इसलिए ये सारे notes log के अंदर आ रहे हैं. फॉर्मूला नोट्स जो होंगे हर सब्जेक्ट के लिए एक ही पीडीएफ होगी. दैट विल बी कंटेनिंग द इम्पोर्टेंट नोट जिनके बेसिस पे आपके पास ट्रू फॉल्स क्वेश्चंस आते हैं या फिर सेलेक्ट करनी होती है आपको स्टेटमेंट्स, और इम्पोर्टेंट सेट ऑफ फॉर्मूलाज विल बी देयर. डिटेल नोट में क्या होगा, फॉर्मूला कहाँ से आया, कैसे डेराइव किया, दैट विल ऑल्सो बी देयर. But in formula notes, it won't be there. In the formula notes, we'll be having only the important points, whereas in the detailed notes, we'll be having the sufficient number of examples to prove that point. Okay, so explanation is available under the detail notes. Formula notes basically जब आपको exam देने में कम time है, quick revision चाहिए, तो उस time पे हम formula notes use करते हैं, and these are really very helpful. I was talking about the courses. So if you see here, full courses, काफी सारे हैं, Gate Forum, Digimento, Nimbus Learning, and it's by me and my team. So all these sessions are in the English language. That's a combination of Hindi and English. तो आप अपनी convenience के according, अपनी pace के according इन sessions को कभी भी देख सकते हो. So these are the benefits of the super coaching, and if you are interested in that, you can opt for any of the plans. So we have three plans for the same: 1 year plan, 2 year plan, and 3 year plan. You can see that 1 year plan is for 13,499, but this is the discounted price. ये discount कब मिलेगा? When you are going to apply the coupon code, that is Shefali S. That's given in the description box, right? So here you have to use the coupon Shefali. I'm so sorry. S. Okay, so when you will apply this coupon code, then you'll get this price. 1 year plan is beneficial for fourth year students. उनको 2 year plan का कोई फायदा नहीं है, but second और third year वालों को मैं रेफर करूंगी कि बेटा 2 year plan लो, क्योंकि आपको enough time मिल जाएगा प्रिपरेशन के लिए. आप वीडियोस जितनी मर्जी देखो, जितने मर्जी टाइम देखो, 1 साल में सारी देख लो, 2 साल में सारी देख लो, 1 साल में सारी खत्म करके फिर नेक्स्ट कोर्स की देख लो, तो इससे आपको n number of examples मिल जाएंगी. मोर ओवर जो आपके सेकेंड और थर्ड ईयर के सब्जेक्ट्स हैं, जो आप सेमेस्टर में पढ़ रहे हो, उनमें भी क्लैरिटी आ जाएगी. हाउ इज इट इज टेकिंग login time to delete one element? Okay, I hope that this is clear to everyone. So there is one doubt, let's go to that. Here you can see the code is given, that is Shefali S. Let me go back to the main slide. Okay, so guys, so sorry, something is happened. So if I go to the example, all right, you can see here we are deleting the first element in this tree, how many levels are we having? How many levels are there? There are log n levels. जब आपने फर्स्ट एलिमेंट को डिलीट करवाया, रूट को डिलीट करवाया, यू आर रिप्लेसिंग इट विद द लास्ट एलिमेंट, with the root element, right? Because this is going to satisfy the structure property. सबसे पहले structure property को satisfy करना है, that is taking constant time. सिर्फ आपने दो elements को swap करवाया, that's it. But now when you have replaced this element with 5, तो हमें इस tree को heapify करना पड़ेगा. Again we need to check for the order property, right? Worst case में क्या होगा, जो आपने top पे अभी element रखा है, this might be the maximum element. For example, आपके पास 5 यहाँ पे होता, 7 यहाँ पे होता. I could have replaced this with 7. I could have replaced it with 7. तो इस केस में क्या होगा, 7 पहले इस लेवल पे आएगा, फिर इस लेवल पे आएगा. How did you reach to the conclusion that it will take login time? I guess you missed one point. I didn't directly reach to the conclusion. Here we said that when I deleted the first element, it is taking login time. When I'm deleting the second element, it's again taking login time, approximately login time, right? When I'm deleting the third element, it's again taking approximately login time. So one by one, when I'm deleting all the elements, so in total it is taking n login time. I hope this is clear now. Let me take one example. Let's assume that we have a tree like 1. Here we have 3, 2, or okay, and here we have 6, 5, 4, 7. If this is the tree, I'm going to delete the root element. अगर मैं इस element को delete कर दूँ, this will be replaced with 7. तो ये यहाँ पे आ गया और ये यहाँ पे आ गया. चलो ठीक है, 7. और आपने इस एलिमेंट को डिलीट करवा दिया, दिस स्लॉट इज एम्प्टी. दैट विल बी टेकिंग कांस्टेंट टाइम. यहाँ पे आपने सारे लेवल्स चेक नहीं किए, बट आफ्टर स्वैपिंग दिस एलिमेंट, आफ्टर डिलीटिंग द एलिमेंट, इज इट अ मिनी ट्री? जब भी आप कोई भी ऑपरेशन परफॉर्म कर रहे हो किसी भी डेटा स्ट्रक्चर पे, तो उसकी प्रॉपर्टीज चेंज नहीं होनी चाहिए. नाउ दिस इज नो मोर अ मिनी ट्री. आई नीड टू कन्वर्ट दिस टू मिनी ट्री. ऑलरेडी स्ट्रक्चर प्रॉपर्टी सेटिस्फाई हो रही है, ऑर्डर प्रॉपर्टी के लिए क्या करेंगे, वी विल चेक दैट वेदर दिस ट्री, whether this node satisfies the heap property. No, the smallest. I'm performing here the first swap. I'm performing here the first swap, so 7 is coming here. Now 7 is compared with 4. So 4 is smaller, so again the swapping is taking place. हुआ क्या, रूट लेवल से चलकर एलिमेंट कहाँ पे पहुंचा, रूट पे था, और वो इसमें it will start from the root and it will reach to the last level. How many levels are there? Log n levels. Approximately log n levels होते हैं. I hope it is clear now. Any other query? So this Saturday and Sunday, I'll not be taking any session for the gate. So Saturday and Sunday, I'll be just taking one session. दोनों दिन एक session होगा. That will be at 7 p.m. and that will be for ISRO people, ISRO PYQs or from ISRO. VSDA questions करेंगे ISRO से, and session time is 7 p.m. and this will be a YouTube session. आप लोग जो भी गेट के लिए प्रिपेयर कर रहे हो, यू ऑल कैन अटेंड दिस सेशन बिकॉज आई विल बी टेकिंग द क्वेश्चंस फ्रॉम द सब्जेक्ट्स व्हिच आर देयर इन द गेट सिलेबस एज वेल. दिस सेशन विल बी बेनिफिशियल फॉर गेट एस्पिरेंट्स एज वेल. ओके, and from Monday we will be starting with the next algorithm designing technique, that is a greedy technique. Anyone having any doubt or inquiry? If I talk about complete schedule, then Monday to Friday, किसी ने starting में पूछा था, Monday से Friday बेटा 2 sessions होते हैं, एक YouTube पे, that starts from 4 p.m. it goes till 5 p.m. and second session is at 8 p.m. to 8:30. In the YouTube session, the YouTube session. In this session, I am covering the concepts, and in this session, we are covering the previous year questions. Okay. Saturday and Sunday, sometimes I take both the sessions like on ISRO and GATE, and sometimes I take only one session ISRO and GATE. तो Saturday और Sunday को मोस्ट प्रोबेबली सिर्फ इसरो का सेशन रखा करेंगे. इससे क्या होगा कि गेट वाले स्टूडेंट्स को भी चांस मिल जाएगा टू अटेंड द इसरो सेशन. ओके, I guess that is better approach instead of having both the sessions, so it will be tiring for you guys क्योंकि weekend है उसमें थोड़ा सा enjoy भी करने. So now onwards we will be just having one session, that is for ISRO. Will it go? Sorry. So this is for ISRO. Guys, from next time मैं उन लोगों की queries नहीं लूंगी जो question पूछ के मैं आंसर देती हूँ और उसके बाद they are not even bothered about giving the confirmation. इसरो तो जिन लोगों ने इसरो का फॉर्म नहीं fill किया है बेटा कर लो. मैं बहुत दिनों से आपको बोल रही हूँ because deadline is approaching, that is on 14th of June. Deadline is on 14th of June. So if you are eligible, then please fill out the form and please take care of this age limit. This time instead of 35 years, this is 28 years. And in total for computer science 47 vacancies are there. Almost 3.5 साल के बाद vacancies आएंगे, तो maximum benefit लो. और आप में से कुछ students ऐसे भी होंगे जिन्होंने GATE 2023 दिया था, but due to some reason they couldn't perform well in the exams. This is a very good opportunity for you guys. Okay. So this is all from my side. If you have any doubt or query, you can ask. Otherwise, we'll end our discussion here. That's clear. All right. So now I'll see you at 8 p.m. in today's session. I'll be discussing the previous year questions from solving the reference relation. कल हम लोगों ने कुछ questions किए थे. Majorly we covered the questions till 2021 or 20. उसके आगे के questions हम आज वाले session में करेंगे. Okay. So take care, guys. See you at 8 p.m. Bye bye.